Did you know that milk is an excellent source of hydration? Milk contains a high percentage of water, making it a great way to quench your thirst. In fact, milk is approximately 87% water, which helps replenish fluids in your body and keep you hydrated. So, if you're looking for a refreshing drink to stay hydrated, a glass of milk can do the trick. In today's video, we will be discussing about the life cycle of milk from the raw material extraction until the end of its life. In this video, it will be covering the introduction to milk, life cycle of milk, the environmental impact, mitigation, as well as the conclusion of the whole life cycle of milk. Now, moving on to the brief introduction of milk. What is milk actually? The mammary glands of female mammals, including cows, goats, and sheep, generate milk, a nutrient-rich fluid. It is often consumed as food or included as an ingredient in a variety of recipes and drinks. Milk is an excellent source of calcium and vitamin D, and is made up of water, fats, proteins, carbohydrates, vitamins, and minerals. Moving on to the history of milk. In the late 1800s, the practice of pasteurizing milk was first introduced by the early 1900s. It had gained widespread acceptance. This increased the safety of milk consumption and facilitated the expansion of industrial-scale dairy farming and milk manufacturing. Now, let's look at the life cycle of milk. The basic life cycle of things usually starts from raw material acquisition, processing, manufacturing, product life until end of its life. But in life cycle of milk, we'll start with feed production and cow rearing, production, transportation, processing and distribution, consumption, and end of life. On feed production and cow rearing stage, sustainable feed sources such as grass-fed or locally sourced feed. The care and management of dairy cows such as feeding, breeding, and health management. In this stage, daily total energy consumption, including milking unit and air compressor, range between 45 and 81.3 kilowatt hours, where the number of herds are 1,539. On milk production stages, the milking process can be done manually or using milking machines. The milk is typically collected into a bulk tank, where it is cooled to maintain freshness and quality. Milk production involved 9,155 TFPCMB, while in milk transportation stage, once milk is produced, it needs to be transported to processing facilities. This can be done using refrigerated trucks or other modes of transportation. Moving on to milk processing and distribution stage. The milk is pasteurized to kill harmful bacteria and homogenized to prevent separation of the cream. The milk is then packaged into various containers and distributed to retailers or consumers. Processing involving pasteurization and homogenization. Distribution involve retail distribution, storage, and warehousing, where include a mean of 3,500 milliliters and a standard deviation up to 150 milliliters. In consumption stage, consumption of milk is the stage where milk is consumed by humans. Milk is a nutrient-rich beverage that is widely consumed around the world. At the last stage, the end of life of milk refers to the disposal or recycling of milk containers once they have been used. Moving on to environmental impact of milk. The first impact is global warming potential, GWP. The average of GWP resulting from the production of 1 kilogram of fat and protein-corrected milk, FPCM, was 1.3 for kilogram CO2, ranging from 0.95 to 1.88 kilograms. The largest contributor was anaerobic fermentation, accounting for 50 to 55% of the total impacts. Feed production was the second largest at 24 to 28%, while manure management the third largest at 9 to 11%. And the contributions of feed transportation and on-farm energy use were 5 to 7%. And 4 to 8% of total impacts, respectively. Moving on to the second environmental impact, eutrophication potential. The eutrophication potential was 9.27 g/43 kg1 fat and protein-corrected milk (FPCM) on average, and varied from 5.88 to 13.32. It was strongly influenced by manure management. Average of 90% of the total impacts, which was related to emission of NH3, leaching and discharge of N and P from animal manure. Feed production accounted for 10% of total eutrophication, due to emissions of NH3 and leaching of NO3 from mineral and fertilizer application. The third environmental impact is acidification potential. The average acidification potential from the production of 1 kilogram of fat and protein-corrected milk (FPCM) was 19.5 grams SO2 with a variation from 13.0 to 27.3 grams SO2. As for eutrophication, manure management contributed the greatest proportion to the acidification, accounting for an average of 79% of the total impact, followed by feed production 18% of total impact. The last environmental impact from life cycle of milk is non-renewable energy use and land occupation on average. The production of 1 kilogram of fat and protein-corrected milk (FPCM) required for 0.91 megajoules non-renewable energy, with a range from 3.73 to 6.73 mJ. The greatest contributor to energy use was feed production, accounting for an average of 64% of the total consumption, followed by on-farm energy use 19% of total and feed transportation 17% of total. The total land used for milk production was 1.83 square meters per kilogram FPCM, ranging from 1.16 to 2.49, of which 98% was required for cultivation of feed crops. Dairy farms only occupied about 2% of the total area, since these farms did not consist of any cropland and all their feed was bought in. Now, we're moving on to mitigation of life cycle of milk. The first one is enhancing milking cow productivity. Improving milking cow productivity can help to reduce the environmental impact of dairy farming. By producing more milk per cow, farmers can reduce the number of cows needed to meet demand, which can help to reduce greenhouse gas emissions and minimize the use of resources, like land and water. The second mitigation is return manure to nearby croplands. Manure is a valuable source of nutrients, including nitrogen, phosphorus, and potassium, which are essential for plant growth. By returning manure to croplands, farmers can effectively recycle these nutrients, reducing the need for synthetic fertilizers. This not only helps to conserve resources, but also reduces the environmental impact associated with the production and application of chemical fertilizers. The third mitigation is increase efficiency of nutrient recycling. Nutrient recycling reduces the reliance on synthetic fertilizers, which often require intensive manufacturing processes and contribute to greenhouse gas emissions. By efficiently recycling nutrients, we can reduce the environmental impact associated with the production and use of chemical fertilizers, including energy consumption, pollution, and nutrient runoff that can lead to water pollution. The last mitigation is combining manure management systems. Some manure management systems, such as anaerobic digestion or composting, can promote the recovery of nutrients in a more concentrated and stable form. By combining these systems, farmers can maximize nutrient recovery, making it easier to transport and apply the nutrients to fields efficiently. This helps to minimize nutrient losses and improve the effectiveness of nutrient recycling. Now, the last part of the life cycle of milk, the conclusion. The life cycle assessment of milk is a comprehensive analysis of the environmental impact of milk production, from the farm to the consumer. The results of a life cycle assessment of milk can vary depending on a variety of factors, including the production system, geographical location, and management practices. A life cycle assessment of milk can help identify areas where improvements can be made to reduce the environmental impact of milk production through the adoption of sustainable practices and technologies. The dairy industry can continue to meet growing demand for milk while minimizing its environmental footprint. Thank you for watching and listening.